Okay, so welcome back, students. So remember the last time we were talking about the computer memories and the architecture, the computer organization, as well as the architecture of the computer. So in this lesson, we are going to talk about the input and output organization. So we are just adding up from the memory of the computer. Now we are talking about the input and output of the computer. So, well, let's get in. So, then what is now the input-output subsystem or organization? Now, with the input and output of a computer provides an efficient mode of communication between the central processing, the central process system, and the outside environment. When you're talking about the central system, we mean the RAM and the CPU, including the memories. Okay, so we are looking at the RAM, memory, RAM, and the CPU. That is the central system. Now it provides them the communication between those ones and the outside environment. When you're talking of the outside environment, we're talking about us users when you're using those devices to communicate with the inside central system. So that is the job of input and output. So it does handle all the input and output operations of the computer. That is actually the job of the input and output subsystem. Okay, talking of that, this input and output, they are referred to peripheral devices. So with the peripheral devices, these are input and output devices that are connected to computer. Any device that is connected to a computer is then referred as a peripheral. Now, this input and output are connected to the computer through cables. Of course, there are some that are connected wireless, for example, either using Bluetooth or you can use internet, but most of them are connected using cables and through ports and ports and other output holes that will allow a user to plug in, okay, and sockets, all those. So these peripherals, that's how they are connected then to a computer. These devices are designed to read information into the computer and to read out or to read out information into the memory unit of the computer. Okay, so and all these are commanded by the CPU. Now, they are then considered to be part of the computer system. Remember when we're defining a computer system in the first unit, we said what a computer system is. It's a combination of or integrated of related components that are working together to achieve then this objective of storing, of sharing of resources. So then inputs and outputs, then they become part of the computer system. Okay, so all these devices that are connected to the computer anyhow, however way, they are called peripherals. Okay, so let's look at this picture here. Okay, it's a picture that I just took from Google there and I place it here. So look, all this, okay, whether it's going to be a memory card, or it's just going to be a simple USB, or it's just going to be a written a ROM, then, or it's just going to be a simple phone, or anything that you attach to the computer to make up the system is considered to be a peripheral. Okay, so I really hope that is very much clear. So we have types of peripherals. They are grouped into three actually. We have three types of peripherals, okay, which is an input peripherals, an output peripherals, and two-in-one peripheral. Okay, so those are the peripherals that we have. Oh my God, my computer almost went off. Thank God. So we have the inputs and outputs. We have the combination, okay? And the combination, as long as it's something that will allow you to enter information as well as to receive the information, and it's actually one device, okay? As long as it's one device, such as a touch screen. But when it comes to input peripherals, these are definitely the ones that are allowing users to put in information inside now the computer. And the output is giving you out the information or the data from the computer. So I hope those two are very much clear. And the examples, as they're saying, the mouse, the keyboard, that is the input. While when it comes to the monitor and the printers, those are considered to be the output. And when we have the input output, that is the touch screen. So please do remember that. Okay, moving on from the peripherals now. These peripherals, they somehow need to connect and communicate with the central processor, okay, with the central processor as well as the RAM. Now, for that to happen, there is a need of an interface. There is a need of an interface, and then interface is actually that share the boundaries between the separate components of the computer system, which can be used then to attach two or more components for communication purposes. So in another word, now you have a mouse, we have a certain device, and this device needs to communicate perhaps with a RAM or with a CPU. Then the interpreter then becomes the boundary wall, is the one that will allow them these two devices to communicate. Because then the CPU, most of the time, that is a digital device, is an electrical device, and it's a digital device, which is an electrical device. The other ones, especially the peripherals, they are usually considered to be electrical wired. So these are two different devices that needs to communicate. So then the interface becomes the intermediate. So this is how it looks like. So here is a processor, then you need the interface here, and you have the external devices such as the keyboard, the mouse, and so forth. So for them now to share data here, there is an intermediate that is needed, which is basically the interface. So then it is the one that facilitates the communication, and this data bus, the address bus, and the control bus. So for them to reach the processors, it can be a processor, it can be a RAM. So it needs this to communicate between the external devices. That becomes the interface, right? So now having an interface, within the interface now, I have spoken about these three, that there is this communication, then it's done through buses such as the data bus, address bus, as well as the control bus. Now, talking of a bus, what is a bus then? Now, when we're talking of a bus, okay, it's for transportation. It's for moving, okay? It's for carrying, in another word. So computer buses are electrical wires which connect hardware component in the computer system. Okay, they connect the components in the computer system. So what is their job? They carry the data, the signals, the resources, the instructions, and power within the computer components. That is the job of a bus. Okay, so that's why they are called bus system. That is a bus system. There are different types of buses that are out there, and they do different kind of job as well. Okay, so let's look at how these buses look like. Some of them, they are on the motherboard. These are internal buses that are designed on the motherboard itself. I'm sure you have seen them. But then some of them, these are electric wire which connect these components. So we have both of them here. So we have an internal bus. You can see how they look like. So this is the drawings that you always find on the motherboard itself. And then we have the external buses. The external buses, some of them like this one, you can see this is the F32 a 32 bit, so meaning it's the length is a little bit smaller. And then we have a 64 bit, and we have other external buses. These are, remember, they are electrical wires. So when you find all these buses within the computer, and I'm sure when we're opening out and assembling and reassembling our components in the computer, you have seen that you saw this on the motherboard, and you also saw all these cables that are connected now, either coming from the power supply to the hard drives, or just the buses themselves that are coming from the power supply to the motherboard itself. So these are the two common buses that we have. But we also have other types of buses, such as these ones here. Okay, the internal, the external, the ones that I gave in you, the two the two common ones. These are the internal as well as the external, like I have shown you there. But we also have these other ones, the data bus, the address bus, as well as the control bus. And you have seen this when I was talking about the interface, that the interface uses then the data bus, the address bus, as well as the control bus to communicate now with the processor and the rest of the computer system. We also have the system bus, expression bus, as well as the input and output buses. So these are some of them that you can go and read in more details. So if you want even more lessons, you can go to www.learncomputerscienceonline.com. They have also a sort of information to explain into details of what these buses and their functions. So talking of the bus, remember we talk of the interrupters, not interrupters, we'll talk about interrupters very soon. Remember, we also have spoken about the interface, okay? Remember we spoke that we have different peripherals. And for those peripherals now to communicate with the central system, there is a need of an interface, okay? Now these interfaces, then they work with the buses. The buses is there to carry out the data, the signals, the power, the instructions within the computer system. Then that brings us to interrupters. Okay, to interrupter. Okay, this interrupter, these are actually these are actually signals, okay, which is generated by external device, which requires then a CPU to perform a task. An example that has been given here is that, suppose, when we are busy, the CPU is busy working right now, okay? Let's imagine this. Now that I'm using my computer, the CPU is busy working, doing some instructions and doing the arithmetic and control, whatever that it needs to do, executing some instructions and processes. And here I am as a user, I need to use the keyboard and the mouse, but this is not, the CPU doesn't know that I'm going to use the keyboard and the mouse, or anything can happen here, or I'm going to plug in my USB. So now, because those are some of the things that human beings do with their external devices, so when you plug in a mouse, or when you start using the mouse, of which, because the CPU was already busy doing something, here is the CPU, and this is the external devices. So suppose this is the keyboard that we are talking about here. And this, now what happened when you are using the mouse, because the CPU was already busy doing some other businesses, okay, such as displaying this this program, which is a PowerPoint. Okay, so when you type something on the keyboard, then the interrupter here, the controller, the interrupter, which is the signal, it needs to send then to the CPU and say, sorry, let's distract you a bit, pay attention to this. Okay, pay attention to the keyboard. So that is the job of the interrupter. So if you're using a word processor and press a key, the program must process the input immediately. And because the program needs to input this output immediately, and the CPU was actually busy on something else, it needs to interrupt the CPU, whatever the instructions that was, or the function that the CPU was doing needs to somehow stop, so that it can attend then to respond to the request of the keyboard. I hope this makes sense. Okay, so we have two types of interrupt. There are two main type of interrupters. We have a hardware interrupter, and then we have software interrupter. Okay, within the hardware interrupter, so this is a signals generated from the external devices. Okay, so the keyboard, the mouse, anything else that you need to plug in, and you want to use them, then they need to go and interrupt the CPU. Okay, then we have two types of hardware interrupters as well. Okay, one, we have a maxable, okay, interrupter. So with the maxable interrupter is that with this one is a non-negotiable interrupter. You don't interrupt these interrupters. They don't allow to be interrupted. They don't what do I have to say? They don't request for priorities. It doesn't consider priorities. But when it comes to non-maxable, then it can actually be interrupted. You can actually go and interrupt. You can it can attend to priorities. Okay. Then within the software also, this one is actually from the internal devices as well as other software programs that needs to be accessed. Okay, so with the first one then, that we have the normal interruption that would just come from a request, a normal request that is coming either from a software that will come from the internal device. That does happen. That is a normal interrupter. And then we have exception. Now with the exception, these are unplanned interrupters. You notice when you are going to be in a developing class, you also, when you are developing your system or your softwares or any programs, remember you need to put in some exception handling just to prevent those unplanned interruptions. You wouldn't want that, but this occurs mostly, errors and whatnot. So that is the exception interrupter. So, and that is from the software. Okay, then we are looking at, knowing that we have interrupters. Interrupters, they also now works with a DMA, which is a direct access memory. Please do not confuse the direct access memory with the interface as well as the interrupters. Remember, interrupters are signals sent to the CPU to pay attention to the request of the devices and softwares, while then an interface, it just intermediates, or it just coordinates the communication between two devices, especially from the external devices to internal devices. But when it comes to direct memory access, now with this one then, it is a control unit. It's also part of the input and output interface. Okay, it's part of input. I'll repeat, it's part. Okay, it's part of input and output interface. Okay, what it does is it transfers data between the devices as well as the main memory faster without then involving the CPU. Okay, it does not involve the CPU when it transferring these data from, remember, these are data, not signals. With the interrupter, those are signals that disrupt the CPU to pay attention. When it comes to direct memory access, this ones then is just facilitates or controls the transfer of data between the RAM and the input and output devices without interfering the CPU. This is data that we are talking about, not signals. Okay, like how it has been shown in this image. So you have, and remember, this is where also the interface are between the other devices and the output and output external devices. So it's here to do that control. Okay, so we are done now with direct memory access. So the last two things that we are going to talk about, these are data converters. Okay, so when you are converting data from one to another signals, in this case, it only works really between the analog conversion as well as a digital signals into analog. So when you are doing the digital to analog converter, when you're talking about digital analog converter, you are just talking about a converter that is taking from a digital signal into an analog format. Okay, so you can actually see that digital, there are zeros and ones, and when it comes to analog, and this one is mostly in the phones and other signals of analog. So you can see these are lines. It's a line. So data needs to be converted within now the computer system. And vice versa, when you are talking of analog to digital, basically you are just converting converting analog signals, usually into voltage obtained from the environment, physicals, phenomenon into a digital format. Okay, so that now brings us to the end of our this is the source where we got all the information that we put here. You can go and read further. But kindly know, we have spoken about the input and output subsystem. So you go and read about it more, get more information. This is the introduction of it. Remember, we have the peripherals. With the peripherals, there is a need of ports that connects and cables that connects the peripherals to the computer. Within now these peripherals, you also need to know that you need an interface. The interface then or coordinate the communication between one device and another device, okay, so that they can share. And we have also spoken about the interrupters. We've spoken about the direct memory access, and and of course we have also spoken about the buses that carry out this information from one device to another device. And that brings us to the end of this. And I thank you. So I'll see you in the next class when we are going to talk about the CPU design. This time we are going to talk about the CPU design. So stay tuned until next time.